Blockchain technology. With the invention of Bitcoin in 2008, the world was introduced to a new concept, which revolutionized the whole of society. It was something that promised to have an impact upon every industry. This new concept was blockchain, the underlying technology that underpins Bitcoin. Distributed systems. Understanding distributed systems is essential to our understanding blockchain, as blockchain is a distributed system at its core. It is a distributed ledger that can be centralized or decentralized. A blockchain is originally intended to be and is usually used as a decentralized platform. It can be thought of as a system that has properties of both decentralized and distributed paradigms. It is a decentralized distributed system. Distributed systems are a computing paradigm whereby two or more nodes work with each other in a coordinated fashion to achieve a common outcome. It is modeled in such a way that end users see it as a single logical platform. For example, Google's search engine is based on a large distributed system. However, to a user, it looks like a single, coherent platform. It is composed of processes, nodes, and channels, communication channels, where nodes communicate by message passing. A blockchain is a message-passing distributed system. A node is an individual player, a computer, in a distributed system. All nodes can send and receive messages between each other. Nodes can be honest, faulty, or malicious, and they have memory and a processor. Layman's definition: blockchain is an ever-growing, secure, shared record-keeping system in which each user of the data holds a copy of the records, which can only be updated if a majority of parties involved in a transaction agree to update. Technical definition: blockchain is a peer-to-peer, distributed ledger that is cryptographically secure, append-only, immutable, extremely hard to change, and updatable only via consensus among peers. Now, let's examine things in some more detail. We will look at the keywords from the technical definition one by one. Peer-to-peer. The first keyword in the technical definition is peer-to-peer, or P2P. This means that there is no central controller in the network, and all participants, nodes, talk to each other directly. This property allows for transactions to be conducted directly among the peers without third-party involvement, such as by a bank. Distributed ledger. Dissecting the technical definition further reveals that blockchain is a distributed ledger, which means that a ledger is spread across the network among all peers in the network, and each peer holds a copy of the complete ledger. Cryptographically secure. Next, we see that this ledger is cryptographically secure, which means that cryptography has been used to provide security services that make this ledger secure against tampering and misuse. These services include non-repudiation, data integrity, and data origin authentication. Public key cryptography, which introduces the fascinating world of cryptography. Append-only. Another property that we encounter is that blockchain is append-only, which means that data can only be added to the blockchain in time-sequential order. This property implies that once data is added to the blockchain, it is almost impossible to change that data, and it can be considered practically immutable. In other words, blocks added to the blockchain cannot be changed, which allows blockchain to become an immutable and tamper-proof ledger of transactions. Updatable via consensus. The most critical attribute of a blockchain is that it is updatable only via consensus. This is what gives it the power of decentralization. In this scenario, No central authority is in control of updating the ledger. Instead, any update made to the blockchain is validated against strict criteria defined by the blockchain protocol and added to the blockchain only after a consensus has been reached among a majority of participating peers nodes on the network. To achieve consensus, there are various consensus algorithms that ensure all parties agree on the final state of the data on the blockchain network and resolutely agree upon it to be true. Blockchain layers. Lowest layer is the network, which is usually the internet and provides a base communication layer for any blockchain. A peer-to-peer network runs on top of the network layer, which consists of information propagation protocols such as gossip or flooding protocols. After this comes the cryptography layer, which contains crucial cryptographic protocols that ensure the security of the blockchain. These cryptographic protocols play a vital role in the integrity of blockchain processes. Secure information dissemination and blockchain consensus mechanisms. This layer consists of public key cryptography and relevant components such as digital signatures and cryptographic hash functions. Sometimes, this layer is abstracted away because it plays a fundamental role in blockchain operations. Next comes the consensus layer, which is concerned with the usage of various consensus mechanisms to ensure agreement among different participants of the blockchain. This is another crucial part of the blockchain architecture, which consists of various techniques such as SMR, proof-based consensus mechanisms, or from traditional distributed systems research, Byzantine fault-tolerant consensus protocols. Further to this, we have the execution layer, which can consist of virtual machines, blocks, transactions, and smart contracts. This layer, as the name suggests, provides executions services on the blockchain and performs operations such as value transfer, smart contract execution, and block generation. Virtual machines such as Ethereum Virtual Machine, EVM, provide an execution environment for smart contracts to execute. Finally, we have the applications layer, which is composed of smart contracts, decentralized applications, DAOs, and autonomous agents. This layer can effectively contain all sorts of various user-level agents and programs that operate on the blockchain. Users interact with the blockchain via decentralized applications. Generic elements of a blockchain. Address. Addresses are unique identifiers used in a blockchain transaction to denote senders and recipients. An address is usually a public key or derived from a public key. Transaction. A transaction is the fundamental unit of a blockchain. A transaction represents a transfer of value from one address to another. Block. A block is composed of multiple transactions and other elements, such as the previous block hash pointer, timestamp, and nonce. A block is composed of a block header and a selection of transactions bundled together and organized logically. A block contains several elements, which we introduce as follows. A reference to a previous block is also included in the block unless it is a genesis block. This reference is the hash of the header of the previous block. A genesis block is the first block in the blockchain that is hard-coded at the time the blockchain was first started. The structure of a block is also dependent on the type and design of a blockchain. A nonce is a number that is generated and used only once. A nonce is used extensively in many cryptographic operations to provide replay protection, authentication, and encryption. In blockchain, it's used in PoW consensus algorithms and for transaction replay protection. A block also includes the nonce value. A timestamp is the creation time of the block. Merkle root is a hash of all the nodes of a Merkle tree. In a blockchain block, it is the combined hash of the transactions in the block. Merkle trees are widely used to validate large data structures securely and efficiently. In the blockchain world, Merkle trees are commonly used to allow efficient verification of transactions. Merkle root in a blockchain is present in the block header section of a block, which is the hash of all transactions in a block. This means that verifying only the Merkle root is required to verify all transactions present in the Merkle tree instead of verifying all transactions one by one. In addition to the block header, the block contains transactions that make up the block body. A transaction is a record of an event. For example, the event of transferring cash from a sender's account to a beneficiary's account. A block contains transactions, and its size varies depending on the type and design of the blockchain.